Hi everyone. So as Ben said, this is going to be a slight change of pace. My name is Vachuska. I've just recently this summer joined Open Networking Lab after about 2.5 decades with Hewlett-Packard, where I also worked on a SDN controller. And so what I'm going to do today is to provide a brief overview of what ONOS is, where it came from, and what its rough architecture is. So it's going to be a little bit of a high altitude flight, so don't expect much low-level detail, but I welcome any questions. So first of all, what is ONOS? Well, it's Open Network Operating System, and it aims to be the SDN operating system for service providers and for their networks. Due to the size and criticality of those networks, it is imperative that it is built around the first principles of scale, high availability, and performance. I think that's fairly obvious, and ONOS is. Also, we're probably all aware of the fact that the networking has evolved fairly smoothly along the data plane, at least I believe it has, due to the sound abstractions. But the control plane, it's a little bit of a disaster, as was indicated earlier in the talks. We're still walking hunched. And so it's important for a controller to, as for any software system actually, is to be built around sound abstractions. So ONOS is built around a reasonable set of abstractions, both around the southern interfaces where it talks to the devices, as well as when it talks to the applications. And I will provide more details on that. And of course, since no software is perfect when it leaves the door, or ever, I guess one could argue, it needs to be modular so that it can evolve along a stable pattern, in a stable way, without, so that when you tug on a certain part of a system as you're trying to improve it, the whole thing doesn't come unraveled because it's all interconnected. So ONOS needs to be modular, and it is. So just to remind everybody, the size and sheer size of the service provider networks. We're talking about large numbers of things. I'm not going to go through the numbers here, but just to remind everybody, we're talking about, tens of thousands of devices and millions of ports. So clearly, this translates into fairly daunting requirements with respect to just sheer throughput of control operations. It's not unusual to have to provision 1 million paths per second, and this is just paths. Now, clearly, that translates into almost an order of magnitude higher number of actually operations on the network state. So it's a lot of lots of frequent operations, and also the size of data is fairly large. Now, of course, we're not talking about big data here, but we have to also remember the fact that lots of these operations are very, very latency sensitive. So it's a daunting challenge, and sometimes it seems to present a dilemma that leads to almost opposite directions, because we're faced with having to do high throughput, low latency, with consistency and high availability. Sometimes these are mutually exclusive, and so one has to be very, very careful how to balance these competing requirements out. And ONOS tries to deal with this by treating different states slightly differently, and I will talk more in detail about that. So why do we call ONOS an operating system rather than just a controller? That's a good question, a fair one. We believe, just like an operating system, ONOS provides a set of very useful services and abstractions to the controller. For example, maintaining connection persistence, maintaining the distributed state. It also provides a framework for driving devices through arbitrary protocols. So it insulates applications from the devices themselves. Operating systems do that. It arbitrates shared network resources and provides abstractions for sharing those network resources between tenants and applications. It also isolates and protects the resources from various tenants and apps, and provides resource virtualization. Now, it doesn't really do that, to be fair, it doesn't do this by itself, but this is where it'll be leaning heavily on virtualization technologies such as OVX and others. And of course, it comes with an SDK, as most operating systems do. So in order to build a scalable system, it has to, and resilient system clearly has to be built on distributed architecture. I think that's pretty much the only way to accomplish this. Now there's different ways to build distributed systems. They can be built in an asymmetric fashion or a symmetric fashion. So ONOS chose the latter just for a number of reasons, and it yields nice simplicity with respect to deployment. Every node in a cluster is outfitted with the same software stack and is capable essentially of doing work of any other node in a cluster. This means that if a node fails, others can swarm in and divide its workload and start executing the work. Let me tell you a little bit about ONOS evolution. It's been actually around for about 2 years or so, but the reason you may not have heard about it was because the early generations were mostly Java, were mostly prototype level quality, and were mostly focused on sort of trying out the basic use cases and basic functionality. They were also primarily focused around OpenFlow 1.0 as being the sole protocol for controlling the network devices. It tried number of the second prototype sort of delved into dealing with performance issues and improving performance at scale, where the first prototype was lacking somewhat. But both of them are prototype level quality code, and both of them relied on OpenFlow as the only means of controlling the network. As far as the release that's coming out in November, as many of you may have heard, like the other previous generations, it's written in Java, but unlike the previous 2 generations, it focuses more on quality and modularity, and also on adding more choices to the Southern protocol. So it's so as part of this, improving the quality and making more robust and suitable for production deployments, we've revamped a number of the northbound and southbound interfaces around the distributed core. We also made significant changes to the distributed core, and we've introduced a new southbound pluggable scheme, where clearly OpenFlow will be the plugin that ON.LAB will provide, but others can build other plugins based on netconf, SNMP, CLIs, or Vachuska for all I care. It doesn't really matter. Of course, as I mentioned, the code base is modular and uses, it's built atop of OSGI container, specifically Apache Carafe. Like the previous releases, the central piece of ONOS continues to be the distributed core, which provides the core functionality of persisting data, distributing it at scale, and making it highly available. Now, the core is sandwiched by 2 different abstraction sort of surfaces, you could call it. API levels that provides appropriate abstraction to the south and to the north. Now, on the southern boundary, the abstractions there, that serves 2 different purposes. One of them is clearly to convey important information to the core, but do so in a protocol agnostic manner. So one of the functions of the southern boundary is to sort of act as a buffer to protect the core from protocol specific details. So no OpenFlow details or any other details specific to a particular control protocol are allowed in the core. The core deals with basically network model, network information base, but it's completely stripped from the protocol specifics. Second function of the southbound interface is to make sure that it elevates the level of language spoken between the environment and the core. We wanted to be careful not to position that level of abstraction to be too low, otherwise we would run the risk of Well, first of all, contouring accidentally a specific protocol such as OpenFlow or netconf. And also, if you position it too low, it would not give enough maneuvering room to the adapter code to adapt to the different behaviors of different protocols. So it's a very, very high level of abstraction. Things like link vanished, link detected. Clearly, they carry, a significant piece of information, but the information has been stripped away from protocol specifics. Now, on the northern boundary of the core, the surface looks a little bit different, but again, it's intended for applications and it's intended to be used by various control components. And some of the abstractions there, of course, they include just a network graph as the previous versions of the operating system did, but they also include some new additions to this. For example, intent framework, and I'll talk more about that. Well, right now. So what is intent frameworks? What is intent? It's essentially a way for an application to specify what should be done rather than how it should be done. Imagine driving with your buddies in a car somewhere and they each telling you which way to go and you're at the wheel. You go crazy. So it's best if they stop doing that and if instead they tell you where they want to go and then you choose the best route to get there. This way, it gives, first of all, it elevates, again, the level of language spoken between the application and the controller or the operating system, as well as it gives the operating system an extra degree of freedom, or degrees of freedom, really, in choosing how to go about accomplishing the objective. So the intents are essentially just specification of what ought to be done. And then these get broken down into lower-level actionable objectives, which then get executed. An example is a host-to-host connectivity intent, which implies bidirectional connectivity for two instations on the edge of the network. It gets broken down into two single or unidirectional paths, and those get broken down into individual flow rules or whatever other edicts are required to provision that connectivity. So once those instructions are then committed to the environment, in this, this case, for the sake of example, we can say the flows are deposited into the environment. The resources resources required by those paths are then monitored, and if a link vanishes or lambda becomes available, whether it's a positive event or a negative event, the framework can step in and either retract the objective, mark it as undoable, or try to find a different path to make the objective accomplished. Or it can declare failure and notify the application saying this is not possible anymore. But it provides sort of a level of autopiloting for your network as far as the applications are concerned. They express their desires and they're either notified whether it can happen or thing will continue to persist, and they don't really need to know whether, for example, a link went down in an ECMP fabric. There was another path, and we took care of it for you. So as far as the distributed core, some of the enhancements that are being made, I alluded to this earlier, where we basically, in the past, we tried to treat all of the state the same. And we tried to decide, okay, is it going to be eventually consistent? Is it going to be strongly consistent? There was a problem because different state needs to be treated differently. And so we've learned from that, and we're applying this philosophy in a new release of ONOS. And specifically, there's 3 different types of high-level methods that we use for replicating and protecting the state. One of them is full replication, and this is for the network graph, for example. It's fully replicated, but eventually consistent. It's important that everybody's on the same page, but it doesn't really matter if everybody's on the same page at the same time, because after all, links, even the links themselves, so pour down events will be perceived differently. So there's already inherent inconsistency in the statefulness. So it doesn't matter if it carries a little bit of layer of abstraction higher. What's important is that it converges quickly, but we don't need to get too hung up about it. So we sort of go with the flow. So that's an example of where we use full replication, is for network graph. For example, for flows, for synchronizing the flow rules, like in a global authoritative flow table that's distributed across the whole cluster. It's important things are protected, but generally in that case, the master controller is the authority, and the information flows from him or it to the slaves. So it's very directed. And so for flow rules, for example, we use essentially sharding along the master-slave or master backup replication. In terms of the intents, as I alluded to earlier, those, for example, we treat in a way where they're strongly consistent because they involve making reservations on the network resources. For example, reserving lambdas, we better make sure that we are the only ones with that lambda, because otherwise, if we have multiple people sending the same wavelength, that would be a mess. So for that, we use strong consistency and shard it. It's meaning that no node has the full state, but there's always more than one node with a piece of the state. Now, one specific bit of the eventual consistency that I alluded to with the network graph, rather than using something like Cassandra or MongoDB or other type of replication technologies, we actually have developed our own, which is based on logical vector clocks, which makes sure that we have ordered delivery of events, and for example, that the cause and the effect don't get out of whack, and so that we end up with actually nicely and smoothly converging network state. This is just another way to look at it. I think I've covered all of this information here. Again, the point here is that different information is treated differently in order to be able to accomplish what sometimes seem to be conflicting objectives. Now, changing pace and speaking about modularity, one of the goals for modularity was to increase architectural coherence. Since we're going open source, that this is extremely important, that we start with a nice and reasonably clean code base that's nicely modular. Otherwise, it's going to be very difficult to maintain the integrity of the system. And so we set up the code base to not only sort of adhere to the architectural tiering and modularity, but also to enforce it whenever possible. We also, this is clearly extremely important to facilitate extensibility that our the partners, which are a lot of them are service providers, require, because they solve their own problems in unique ways. And of course, you know, as software grows larger, it's prone often to sort of code entanglement. And with modules, at least with the Java modules and Maven modules, they prevent cyclic dependencies. And of course, lastly, the modularity was required to enable the pluggable southbound. This is just a quick depiction of a rough high-level inventory of ONOS modules, and more detail will become available on it as we open source. And finally, this is just a summary of what's coming in December 5th when we open source. It's going to be ONOS with all of the key features that I spoke about. Clearly, the code will be available on GitHub, along with a number of use case demonstrations, specifically SD and IP BGP peering, and packet optical integration, and along with a number of sample applications regarding reactive forwarding, mobility, and proxy ARP. And that's all I have. If anybody has any questions.
Hi, my name is Vinay with the eBay PayPal. Is there a support model for this?
I'm sorry?
You said it was open source.
It's going to be open source on December 5th.
I know, but do you also provide a support model with that?
I don't have an answer for that. Clearly, there will be all the necessary collateral. I'm not sure what you mean by support. Clearly, there will be a small, the ON.LAB will continue to own the core architecture and the development of the software, so if that's what you mean.
No, what I mean by that is, like, say some customer came along, said, we would like to deploy your controller and test it in our production environment or like development environment. So there are going to be some issues that we're going to find out. So there will be ongoing support that's required, code changes, integration with other components, things like that. So I was just thinking, do you provide support like that, or is it just open source and people are willing to try it, they use that code and they're on their own?
Well, we'll have Jira, we'll have be doing mirroring the code, we'll have Garrett mirroring the code to GitHub, we'll have Wiki, we'll have Google discussion groups. That's all being set up as we speak. As a matter of fact, a lot of that is already operational. So if by support you mean engaging the community, then yes. If by support means that whether we will be supporting commercial deployments, then probably no. That will be up to our partners who actually take and productize it and harden it the rest of the way.
Thanks, Uri Ilzur with Intel. This is Open vSwitch conference. I didn't hear the word OVS in the last 30 minutes. Maybe
That's
you
right.
could comment on this a little bit.
That's right. Yes, as Ben alluded to, it was change of pace, and it was suggested that I speak to this by Nick and Ben, so I came here to do that. I was not prepared to speak about OVS.
Can you comment on this? I mean, it came across as southbound is open flow only, which is great, but not everything.
That was not my intention. I thought I was fairly clear that the southbound protocol is entirely arbitrary.
Yeah, but in terms of what you provide at time of open sourcing. And so
correct, yes.
Is there any plans you can talk about of how you work closer with this community?
Well, not for this talk, but I can certainly talk with you in a hallway. Yeah.
I guess I think of Open vSwitch as one of the leading OpenFlow implementations, so I would think that it would.
I will add something, which is that, so Ben commented that, OVS is one of the leading OpenFlow implementations, so I think that's really significant, especially considering that ONOS is going to be an ONOS OpenFlow 1.3 compatible controller, so anything you can do with OpenFlow 1.3 on OVS will be hopefully directly controllable by ONOS. I'm also Bob Lance from ON.LAB. I'm one of Thomas's colleagues. And the other thing I think to consider is that there are things that OpenFlow can't do to configure Open vSwitch, things that you have to use OVS DB for, and presumably it may be possible to like implement an OVS DB plugin, which could perhaps allow ONOS to configure certain features of Open vSwitch, which can't be configured directly with OpenFlow.
We have time for another question or two, if anybody has one. Is this working?
Hi, Vikram with Extreme Networks. So you talked about the application intent, talking about what versus how. I was wondering if you have looked at Frenetic and if you have any thoughts about it.
Yes, as a matter of fact, we're having talks with Jennifer and the Princeton team with respect to building Frenetic on top of this. Yep.
Thank you.
Mm-hmm.
Yeah, Nabin Damoni with Metronome. I was wondering how you differentiate ONOS from Open Daylight?
It's a great question, one that comes out a lot. How How do you differentiate an iPhone from an Android? Its competition is good. Whether or not they're slightly different, clearly. We're specifically focused on service provider networks. I'm not sure whether that's the Open Daylight's focus. I'm sure they will be entering that space as well. I think we can all safely argue that a little bit of competition never hurt anybody. It's, as a matter of fact, good for industry, right? I mean, I think we all agree that, as a matter of fact, one of the virtues of SDN is that it hopes to restore competition to networking space. And so why should we stop at the controller? That's kind of my viewpoint on it.
Hi, Frank from Cosmos. Regarding your northbound API, so how can you compare it with group-based policy and from Neutron or Open Daylight?
So, the comparison could be, or the distinction, I should say, could be made along different fronts. The form factor is one of them. The canonical representation of our northbound API is two form factors, one built on top of another. Java API, there's no IDL, and then REST API on top of that. So that's a sort of form factor, or what the API is made of, or what the boundary is made of. In terms of the actual semantic content of it, I'm sure there are similarities. You're dealing with basic abstractions such as devices, links, ports, and so forth, from which one can stitch the notion of a network graph. I believe that's pretty much the same. As far as when it comes to the group policy is slightly different from the intent framework, although it could be argued at high level that they both try to accomplish the same thing. The intent framework is not focused on policy, but also the idea is that it can encompass policy, of course, but it can also deal with connectivity, which is something that the group policy is not, one could argue, is really not intended to do so. And clearly, so those are some of the distinctions and some of the commonalities.
All right, let's thank our speaker.